Let's look at number 9. So let's consider a regular polygon with 15 sides. Calculate the angle of rotational symmetry for the regular polygon. So let's look at our polygon here. So we have 15 sides in our polygon. And we want to know the angle of rotational symmetry. Angle of rotational symmetry. So what we can do right now is we can actually visualize this as it's really hard to visualize a polygon with 15 sides, but you're going to have to in geometry, what we have to recognize that any polygon, the sum of the interior angles is going to equal 360. So sum of interior angles is simply 360 over n, where n here is going to be my number of angles. So that's kind of our formula for our sum of interior angles in a polygon. And what we can do now is or actually sum of interior angles is n minus 2 times 180 actually. So this is actually not the correct formula, sorry. Interior angles and angles of rotational symmetry are two different things. I mixed that up, my bad. Sum of interior angles is n minus 2. So sorry, let me erase this again. It's n minus 2 times 180. So that's a different formula here. But what they're asking here is angle of rotational symmetry. So I actually messed that up here. And it's asking, how can I rotate my my shape to become a shape that's already been rotated, basically. So in order to think about this, let's think about an easier problem first. So let's not do 15 sides, because 15 sides is a little bit hard to visualize. Let's do an angle with 3 sides. So a polygon with 3 sides is simply just a triangle, right? This is our very famous triangle here. And we know that in a triangle here, we have 180. We have 180. Is 180 degrees in our polygon. But we also have, if we want to rotate it, the angles of freedom here is going to be 360 degrees, right? Because if you think about this triangle, we can rotate it this way to get us this triangle, and then we can rotate it again to get us this triangle here, and then so we basically have 4 triangles here, right? So let me draw this out. So this is our first triangle. We can rotate it to get this triangle. If I rotate it by 180 degrees, I can rotate it again to get this triangle here, and I can rotate it to this triangle here. So again, I get 4 different triangles for these guys here, right? And what we can do here is, as you can see, this here, if the angles here are going to make up 360 degrees, right? Because if I take the interior angle here, 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 and here, I have 90 degrees times 4, right? Which is going to give me 360 degrees. And this here is very, very key to how do we rotate these specific angles here. So we're gonna have 360 degrees, and what we can do is we can find out the angle of rotational symmetry on its rotated retains its original position, right? So for a triangle here, we have 360 degrees. We can divide it by the number of sides, which is going to equal 3, and this will give me 120 degrees. So therefore, the angle which I can rotate this point here is from 1 all the way to 120 degrees. So that's the angle of rotational symmetry for a triangle. Now, for a shape with 15 sides, we can simply just apply this formula to this guy here, right? So we have 360 degrees divided by, well, how many sides do we have a polygon with 15 sides? Well, we have 15 sides in that, right? So n here is going to equal 15. So what's 360 degrees divided by 15? This is going to give me 24 degrees. So that's going to be our angle of symmetry. And as you can see, this solution is correct as well. So therefore, angle of symmetry, or rotational symmetry, sorry, for polygon with 15 sides is 24 degrees. And this here solution here is correct.